What's up, Math 1 students? This lesson is on 7.d, which is I can identify the key features of a function. Now, the more you understand about graphing and the more you understand about domain, range, and try to learn and understand these definitions, the easier this becomes, okay? So the first thing we're going to discuss is what the x-intercept and y-intercept are. Now, the x-intercept, you have to understand, is the point where the line crosses the x-axis. So if I draw a graph inside this coordinate plane, right, and it's something like, say, this, okay, what you have to understand is the point, right, where the line crosses the x-axis, this is your x-intercept. Now, if you take it and you talk about the point where the line crosses, or the graph crosses the y-axis, right? This here would be your y-intercept. Okay, now think about it. When you're on the x-axis, what is your y value always going to be? Right? Your y value is always going to be 0. So whatever your x-intercept will always be x, comma, 0. Because the y value is always going to be 0. For the y-intercept, what do we know about the x value all the time? The x value is 0, comma, whatever y is. So you have to understand that for the x-intercept, it's always going to be whatever x is, comma, 0. And then the y-intercept is always going to be 0, comma, whatever y is. So when it comes to finding the x and y-intercepts for a function, right? So when I look at this graph is the graph of g of x. When I look at the x-intercepts, the first thing I'm going to do is I'm going to go and highlight all of them. So here's my x-axis, right? So this is my x-axis, and I'm going to put a dot at each of the points where the graph intersects the x-axis. And then I'm just going to identify the ordered pairs. So this x-intercept would be at negative 2, 0. So negative 2, 0. Is one x-intercept. This is at negative 1, 0. That is another x-intercept. This one is at positive 1, 0. So that would be a third, right? That would be a third x-intercept. Okay? Now, the y-intercept, right? If I highlight the y-axis right here, I'm going to plot a point at the intersection of the graph and the y-axis, which is right here. And if I identify that ordered pair, it'd be x is 0, negative 2. So the y-intercept here, 0, negative 2. Okay? So you guys have to understand, like, just plot a dot at the intersection of the graph and the x-axis, identify the ordered pairs. Same with the y-intercept. Now, increasing and decreasing functions. When I talk about an increasing function, a function is increasing when the y value increases as x increases. So when I talk about, like, if I'm in the coordinate plane and I talk about an increasing function, as I move right, my graph goes up, right? So this is when it's increasing, right? As x moves to the right, the y values go up. A decreasing function is the opposite, right? That's when a function is decreasing when the y value goes down or decreases as x. So now, as I move right, my y values go down. Okay, so remember, we always work left to right. Then, finally, constant. Constant means it's almost like the neutral, right? This is almost like the neutral. It's not going up. It's not going down. What this is, right, if the graph is constant, that means you basically are a horizontal line, right? So the y value is not going up and the y value is not going down. So anytime we describe where a function is increasing or decreasing, we always use the interval over what x values is the function in increasing or decreasing. So we always, anytime we describe this, we use the interval of x values right? And that's to describe when the function is increasing, decreasing, or constant. All right. Now, if you think about it logically, we say the function is increasing from here to here, meaning from this x value to this x value and so on. So let's take a look, right, at what this means. So right away, the first thing I do is I identify what we would consider turning points, meaning when it's going from increasing to decreasing, increasing to constant, constant to decreasing, and so on. So if I look right here, if I trace this graph, I notice from here to here, the graph is increasing. Then hits this turning point. And from that turning point to here, that function is constant, right? Then I look, so right there changes again, and it goes back to increasing until it reaches this point, where then it goes back to decreasing again, right? So now it's decreasing there. So right away, we know in the yellow, right, in that yellow area, it's increasing. So we say it starts increasing from out here, and it continues to increase all the way to this point. Since this arrow is pointing to the left, we're going to say it starts increasing at negative infinity, and it continues to go up all the way until it reaches an x value of negative 2. So it's increasing from negative infinity to negative 2. And remember, with increasing and decreasing, we always use round parentheses. Then it starts and it's constant from, right, this negative 2. So it's constant from negative 2 all the way until an x value of 1. Oh, that's decreasing. So let me do this. So it's constant from negative 2 to 1. Then it starts increasing again. And remember, when you have another interval of increasing, we always use a union symbol in between. And we say this is increasing from an x value of 1 all the way to an x value of 3. And then at that turning point, right, it starts to go down again. So we say it's decreasing from 3 all the way to, this arrow points to the right forever and ever, from 3 to infinity. So 3 to infinity is where it's decreasing. So now let's talk about max and mins. Okay, so the first type of max and mins we're going to talk about are the absolute max and mins. Now an absolute max is the y-coordinate at the highest point on the graph or function, and an absolute min is the y-coordinate at the lowest point, right? Now, when I look at the first example here, right, anytime we go to identify max and mins, we say, right, the max slash min is, right, some y value when x is some value. Okay, so right away here, when I look at the first example, first thing I'm going to do is I'm going to kind of like trace the graph, and I'm going to say if I start here and I get right here, this point here is the highest point on the graph, right? Therefore, this is where the max is going to be. Now, as I continue traveling down this hill, we're going to ask ourselves, is this the lowest point on the entire graph? Yes, that is the lowest point, which means it's going to be the absolute min. Now, when I look, the absolute max here is at negative 2, 4. That is the ordered pair which it's at. But remember, anytime we describe an absolute max or min, we say it's the y value. So the absolute max is, right? What is the y value of that highest point? Is for when our x value is what? -2. Okay? Because if you think about it, if we're talking about, profit per year of a company, right? We would say the highest profit was this in this year, right? So we always use the y values to describe the max and mins. Now, the next one for the min, right? We would say this ordered pair is at 5, -3. So we would say the absolute min is -3 when x is equal to 5. Okay? Now, so the next thing we're going to talk about is a relative min and max. Now, relative min is the y value of the highest point in a general region on the graph. And the best way to describe these are, these points will exist when the function changes from increasing to decreasing, right? So if the function is increasing and all of a sudden you see it starts decreasing, right? This would be a relative max. Now, if it's the highest point on the graph, that point could also be the absolute max, right? But if it happens somewhere in the graph within where it's not the absolute max, we would say it's a relative max. And a relative min is the y value of the lowest point in a general region on the graph. And that's when the function is changing direction from decreasing to increasing, right? So we're decreasing and it turns and then it starts to increase. This would be a relative min. So when you look at the first example here, identify the max and mins of this function. Well, right away, you have to know, when I look at this arrow points down forever and ever. That one goes up forever and ever. So this graph won't have an absolute max or min because it never reaches a highest point and it never reaches the lowest point. But what we do say is this here, when this graph goes from increasing to decreasing, or it's the top of a mountain, we would say that's a relative max, right? And then as it's decreasing and switches over to increasing, we're at the bottom of this hill, and this would be a relative min, right? So the relative max here, right, is going to be 3 when x is -2. So we would say the relative max is 3 when x is -2. And we would say the relative min, right, and this point is at 2, -3. So we would say the relative min is -3 when x equals 2. Okay, so again, these are not the highest and lowest points, but if I look, this point here is the highest within that region. This point here is the lowest point within that region. So now let's look at it all right? This is where we start to kind of put it all together. So what do we use to determine if a function or if a graph is a function? We use the vertical line test, right? So if I go and start drawing all these vertical lines, do any of them go through the graph more than once? No. Therefore, we would say that this graph represents a function. Now the domain, from left to right, over what x values does this function exist? Well, it starts at 0 and it goes all the way. And if I look, this arrow tells me it's going to continue going to the right forever and ever. So that will have its domain that starts at 0, and it's a square bracket because we're equal to, and it continues to an x value of infinity because it never stops going to the right. Now the range of this one is a little complicated. Generally, again, for the range, we work bottom to top. But when I look here, this generally, like a lot of times, like 0 would be considered the lowest point. But because this arrow points down and to the right, this will keep going like this meaning the range of this will actually start at negative infinity, right? So we're going to say it starts at negative infinity, and if we trace it all the way to the highest point, right, the highest point is at a y value of 10, and since it's equal to, we use this square bracket. So that infinity part might be hard to understand, right? But it's very important to see that that arrow points down and to the right forever and ever. Now, where is this increasing? Well, I'm going to talk about increasing and decreasing at one time. And I'm just going to trace the graph and say, from the left to right, this first section here, what is the graph doing? It's increasing. Then what happens? It turns a corner and starts to go, went too far here. Turns this corner and starts to go down to here. Then hits that turning point, starts to go up again, and then turns that corner and starts to go down again. So in this yellow, it starts increasing from an x value of 0, and it stops increasing at an x value of 3. So it starts at 0, and it stops increasing at an x value of 3. Now, at 3, it turns a corner, and it starts decreasing at an x value of 3, all the way up until an x value of 5. Then it hits that turning point and starts going up again. So we're going to say the increasing union starts going back up again at 5. It continues going up all the way to a y value, an x value of 9. Then at 9, so I'm going to go union. It starts decreasing again from 9, and then it'll go down all the way to infinity. There is one x-intercept, and it's right here. And that ordered pair is at 0, 0. And same with the y-intercept. This point here, right, that graph crosses the x-axis and y-axis at 0, 0. Is there an absolute min? No, there isn't, right? Because the graph continues going down forever and ever. So there is no, right, absolute min, but it does have an absolute max. And that absolute max is at the ordered pair 9, 10. So we say the absolute max is 10 when x is 9. Now the relative min, right? If I look, this here is the bottom of a hill. So this is going to be a relative min. It's not the lowest point on the graph, but it's the lowest point in that area. So we're going to say the relative min is, what's the y coordinate? So the ordered pair here is 5, 3. So we say is 3 when x equals 5. And a relative max, is there kind of like a top of a hill? Right? If I look, top of the hill is right here. Okay, and that's at an ordered pair of 3, 6. So we say the relative max is 6 when x is 3. Okay, so knowing all of this is very, very important. Let's take a look at another one. Now, the domain of this function, right? Where does it start on the left? Well, if this arrow points down forever and ever, right? That tells me it's starting at negative infinity. And as we follow it, it starts at negative infinity and goes all the way to an x value of 5. So the domain, right, is negative infinity to 5. And since it's a closed dot, we're going to use a square bracket. Now, it passes the vertical line test, so it is a function. When I talk about the range then, if this arrow points down forever and ever, it's going to start at negative infinity and go all the way to the top here, right? And that top is at 5. So we say the range goes from negative infinity to the highest point, which is 5. And it's a square bracket also. Now, as we trace the graph, we're going to identify when it's increasing and decreasing. So from left here all the way to here, the function is increasing, starts turning the corner, and goes decreasing until that bottom. Then it switches again to increasing. Then it comes back down to a bottom, and then it starts increasing again. Okay, so now when I describe these intervals, over what x values is it increasing, and over what x values is it decreasing? So from here, it starts increasing at negative infinity. And it continues to increase all the way to this turning point, which is negative 4. So then at that negative 4, that's where it starts decreasing again. So negative 4, it starts decreasing and goes all the way until negative 1, right? Then at negative 1, I'm going to go union. It starts increasing again all the way to an x value of 2. So it increases from negative 1 all the way to 2. Then at 2, it starts decreasing again. So 2, it starts decreasing all the way to an x value of 4. Then it goes back up from 4, 5. So those are the intervals of x values where the function is increasing and decreasing. Now, x-intercepts, right? When I talk about x-intercepts, first thing I'm going to do is if I highlight the x-axis right here, I'm going to put a dot at all the points where the graph crosses that x-axis. So there are 3 x-intercepts, and now we're going to identify them. This one would be at negative 5, 0. This would be at negative 3, 0. This would be at 1, 0. So the x-intercepts are negative 5, 0, negative 3, 0, and 1, 0. Now the y-intercept, right? The y-intercept, go to the intersection of the y-axis in the graph, which is here, and that's at 0, negative 3. Now, since this graph goes down forever and ever, so this here tells us it points down forever and ever, which means there's no absolute lowest point since that goes down forever and ever, so there's no absolute min. But if I trace this graph, is there an exact highest point? And yes, the highest point here is at 5, 5. So we would say that the absolute max is 5 when x is 5. Now, there's a couple of local mins and maxes, or relative mins and maxes. And if I look here, the top of the hills are maxes, the bottom of the hills are mins. So right here, I look. This is a relative max, right? And that's at negative 4, 3. This here, since it's the bottom of the hill, that's a relative min. Then up here, we're going to get another relative max. And here, we're going to get another relative min. So right away, I know the first relative max, right, is going to be, the first relative max is 3 when x is negative 4. The other one, this is at the ordered pair 2, 3. Nope, sorry, 2, 4. Right, so we're going to say the other max is 4 when x is 2. Now I'm going to switch to relative mins right here. So that's at negative 1, negative 4. So we say is negative 4 when x is negative 1. Then this one is going to be at 4, 1. So we're going to say is 1 when x is 4. So how you identify those is critical. Now last, reading tables. Find the x-intercept of f of x, right, in the table, and find the y-intercept. So you got to remember, the x-intercept, for the x-intercept, y is always equal to 0. So if I look in this table for my y values, right, so the x-intercept is always going to be when y is 0. Here's a y value of 0. What's the x value? -1. So the x-intercept here would be -1, 0. Now the y-intercept is always when x is equal to 0. So if I go to my table, I'm going to look for an x value of 0. And what's the output y value? So the y-intercept right here would be x is 0, y is 3. So again, this is your x-intercept. This is your y-intercept. And finally, right, what is the y-intercept for g of x, right? If I look at g of x, I'm looking for the y-intercept, so I know x is 0. So where is x 0? Right here. And I would say the y-intercept is going to be 0, 6. Now the x-intercept for h of x, right, that I'm looking for when y is equal to 0. So if I go to h of x, I'm going to scroll until I see a y value of 0. Here's another y value of 0. So this graph has two x-intercepts. One is going to be at -5, 0. The other one would be at -1, 0. Now the x-intercept for g of x, right? When I look, g of x, I'm looking, the x-intercept has a y value of 0 right here. That would be the ordered pair 1, 0. The x-intercept for f of x, right? If I look for f of x, I'm looking for a y value of 0, y value of 0, y value of 0. This has 3 of them. So here's one x-intercept, which is at -2, 0. Another one would be at 0, 0. And the third one would be at 2, 0. So remember, x-intercepts always have a y value equal to 0. And what is the y-intercept of h of x? Well, if I look, the y-intercept always has an x value of 0. So when x is 0, right, what is the output y for h of x? 1. So 0, 1 would be my y-intercept. And here, find the x-intercept and y-intercept for the relation. So remember, x-intercepts, right, always have a y value of 0. So there's an x-intercept, y value 0. There's another one. So this actually has 2. So -6, 0 and 2, 0. Then the y-intercept, right, has an x value of 0. And that would be at 0, 12. All right, I hope this makes sense. Let us know if you have any questions.